So the exercise related to the circuit or DC electricity, you don't have the AC circuits in AS. In A2, you have the AC circuits in which alternating current is there in the circuit and you have to work out different parameters according to the question. But this will always be DC circuits like in AS. First 34 questions are already recorded, so we'll start with 35. So in this one, the diagram shows a circuit containing a fixed resistor and a negative temperature coefficient thermistor, which means its resistance changes with temperature. If we increase the temperature, its resistance will decrease. The temperature in the circuit increases. So if we increase the temperature in the circuit, you can use a chat to answer. If we increase the temperature in the circuit, which row in a table correctly shows what happened to the current and the potential across the thermistor? What happened? The current is the total current in the circuit. What happened to the total current in the circuit? And what happened to the potential across this thermistor? And remember, the thermistor is a negative temperature coefficient. So if we increase the temperature, what will happen to the resistance of a thermistor? It will decrease. And if the resistance is directly proportional to voltage, so voltage will also decrease. So here the voltage will decrease and other component the voltage will increase. The sum will remain constant. Like if this is V1 and V2 and total is V, so the sum of V1 and V2 will be constant. V1 is decreasing, so definitely V2 should increase. And what about the current in the circuit? Because this has a fixed resistance and the resistance of this one is decreasing. And the combined resistance as they're connected in series, so the combined resistance is R1 plus R2. R2 is not changing, R1 is decreasing, so the combined resistance will also decrease. And if the combined resistance decrease, the current will increase. So the potential across it, the current will increase in the circuit and the potential across it decrease. So C will be the right answer. The next is, what is the potential difference across XY? The potential difference of the supply is 15 and the fixed resistor is 40 and the resistance of thermistor is 60. So they give potential of a supply is 15, resistance of fixed resistor is 40. This is 40 ohms and this one is 60 ohm. We need the potential here. So whenever two or more resistors are connected in series, we'll use a potential divider formula. What is the potential divider formula? If I say voltage here is V1 and voltage here is V2, so voltage here V1 is the resistance of that part divided by the sum of the resistance of the two component multiplied by total voltage. So the resistance of this part is 60 divided by the sum of the voltage, sum of the resistance 60 plus 40, which is 100 multiplied by 50. So V1 will be equals to 60 divided by 100 into 15. So this 0 will cancel with 0. This will be 3 and 5 and 45 divided by 5. So that is equals to 9. So we got 9 volts here. So this will be 9 volts. So remaining how much voltage will be there? Remaining 6 volts will be there across the fixed resistor. The potential across this one will be 9. So D will be the right answer. In question 37, a student is investigating whether the length of a main electrical cable can be determined accurately by taking the measurement of the resistance using an ohm meter, hence calculating a length. She takes a measurement of the resistance and a diameter of a live conductor as shown in the photograph. She uses the measurement to calculate the length of a cable and then compare this value with the direct measurement of the length. So the setting is there. This is 0.3 ohm and a diameter was 1.08 millimeter and the length was 14.5 meter. Show that the cross-sectional area of a live conductor is about 9 exponent minus 7. So How we can work out the diameter of the, how we work out the cross-sectional area. Area is pi r square, area of cross-section of wire pi r square, or you can use pi d square by 4. Both formulas are valid. Either you convert a diameter into radius and then substitute, or directly use pi d square by 4. So the cross-sectional area will be pi, d is a diameter, pi, the value of a pi is 3.14. D is the diameter, but that is in millimeter. So you have to convert into meter. So 1.08 divided by 1000, or we can say 1.08 exponent minus 3 square divided by 4. What's the answer for the cross-sectional area? The answer for the cross-sectional area, 3.14 times 1.08 exponent minus 3 square, and that is divided by 4. 9.15 exponent negative 7. 9.16, okay, 9.16 exponent negative 7. And the unit will be meter square. So 9.16 exponent, that's, we got the cross-sectional area. Next is calculate the length of a live conductor. So if we need the length, we have the resistivity and we have the resistance as well. So we can use a formula that R equals rho L divided by A. If I need length, so it will be RA divided by rho is equals to L. R is a resistance which was shown in the beginning, that was 0.3 ohm. So this is 0.3. Cross-sectional area, it was 9.16 exponent minus 7. And the resistivity is also given, that is 1.68 into 10 to the power minus 8. So just substitute the values, like the product of this divided by 1.68, that will give us the length of this conducting wire, which is 16.4 meter. That's a length. Comment on accuracy of this method of determining the length. So this was 6 point, this according to this method we got 6.4. And original length 19.6. So when we work out the length, it was 16.4. 16.4 is the length which we got according to calculation of the resistance, and measured length is 14.5. Is this an accurate method of measuring the length? Like what student did, student used a formula that R is equals to rho L by A. And he measured the resistance, he got the area, the diameter, and resistivity, he got the length. And that length was 16.4. But the actual length is 14.5, the measured length. So is it an accurate method of measuring length? So we can compare the percentage difference between, like, how to compare the percentage difference. Percentage difference is maximum minus minimum divided by mean into 100. If your percentage difference is more than 10%, it means that's not an accurate value. Or you have the standard value. So its standard value is 14.5. So instead of mean, we'll substitute the standard value because actually it is 14.5. So the maximum will be 16.4 minus 14.5 divided by 14.5 into 100. What is the percentage difference? 16.4 minus 14.5 divided by 14.5 into 100. Why I took denominator as 14.5? Because, so 12.8 or 13%. So 13% is the percentage difference. For an accurate result, the percentage difference should be less than 10%. 10 or less than 10. So means this is not the accurate method of measuring the length. We'll comment on, it's of only 1 mark. So we can just say the percentage difference between the two values is high. So this is not the accurate method. Why we take 14.5? Because the actual length of the wire is 14.5. The original length standard is like the actual value is 14.5, but our experimental value is 16.4. That's why we compare 16.4 with 14.5. So standard, when we compare a percentage difference, if we have the standard value, then we divide by a standard value, actual value. If you were not having any actual value, both are experimental value. In that case, we'll divide by the mean. The student want to improve, student wants to improve the determination of a length. Explain why she should improve the measurement of a resistance rather than measurement of a diameter. So a student want to repeat the experiment, like she want to improve the determination of the length. And she is determining a length R is equals to rho L by A. So L is equals to RA divided by rho is equals to L. So why she should improve the measurement of resistance rather than the measurement of a diameter or the cross-sectional area, you can say. So main reason is that because for a wire, usually wire is having a uniform cross-sectional area. You don't find a wire which is having a non-uniform cross-sectional area, not like this. The wires are not like this. The wires have uniform cross-sectional area. So the change in the area or the diameter will be negligible throughout this structure, throughout the wire. But what will happen? The resistance can change according to the section of the wire. Is it clear? So the structure of the answer is the change in the area and another thing is the if you compare a diameter and the instrument which are used, you can compare them as well. If you compare to measure a diameter, what was the uncertainty in the measurement? The uncertainty in the measurement was 0.01 millimeter because we use a micrometer. What is the uncertainty in the resistance? 0.1. So means like this will have a greater percentage uncertainty because percentage uncertainty is a uncertainty divided by value recorded into 100. Here, so in this case, if you work out the uncertainty in measurement of the resistance, so this will be 0.1 divided by 0.3 into 100. But for here, the percentage uncertainty will be 0.01 divided by 1.08 into 100. So the percentage uncertainty in measurement of a diameter will be very low as compared to percentage uncertainty in the measurement of resistance. So resistance, that's why we should repeat the experiment or modify the experiment for or change a apparatus for measuring a resistance rather than a diameter. Is it clear, this one? The comparison? Then describe an alternative way to determine the resistance of a live conductor and how it would improve the accuracy. Look, student using a ohm meter and directly measuring. So there is another way of finding the resistance is by taking a ratio between voltage and current. So what we can do, we can measure the voltage by using a voltmeter and we measure the current by using an ammeter. And the and using a more sensitive voltmeter and ammeter, that will reduce the percentage uncertainty in the value of R. Or how we can improve the result is by measuring, connecting a voltmeter and ammeter and plot a graph between voltage and current and find the gradient of the graph. When we find the gradient of this graph, that will give us the value for R. So plotting like measure a voltage and current of the wire and plotting a graph for a set of results, find the gradient. In that case, the gradient will be equals to R. So it will be more accurate method because you are repeating the experiment. You can identify when you plot a graph, you can identify the type of errors like systematic or random errors or anomalies results can be identified from the graph. The device is having absolute uncertainties, but the percentage uncertainty will be there in the calculated values. The device uncertainty is absolute. The main electrical cable is used in extension for a lawn mower. The is labeled 1200 watt and 230 volts. Calculate the operating current. At what current it will be operated. So P equals VI. So we have the power and we have the voltage. So we just divide. So 1200 divided by 230. That will give us the current which will, so 5.2 ampere. Calculate a rate at which energy is dissipated. So energy dissipated, or so E is power is energy divided by time. So if we need energy, it will be power into time. And for that dissipation, we always use a formula I square R, or you can also use this if, sorry. So you can work out the resistance and use the formula P is equals to I square R, where R is the resistance of this. And rate of energy dissipation means power, because they mention if energy dissipation is there, but rate of energy dissipation, like energy loss, that is P is equals to I square R. So power dissipation formula is always I square R, because the current and the resistance both will affect how much energy will be lost. So the current we calculated was 5.1. Why we cannot use P is equals to VI? The formula P is equals to VI give the total power, but how much loss is I square R? Depends on the current and depends on the resistance. Why it is not T here? Because in the question they mention calculate the rate at which energy dissipate. Rate of anything like energy over time. So energy over time is what? It is power. And whenever power dissipation is there, it should be I square R. I is the current which we calculate 5.2 square, and the resistance of this was 0.3 that was there in the beginning of the question. So we just multiply and we know how much power is wasted. To out of 1200, what's the answer here? 5.2 square in, so 8.17 watt. So out of 1200, 8.17 watt will be the wasted power, loss, like loss of energy every second. 8.17 joules. No, it is not watt per second, it will be watt. It is a power, the unit of the power is watts. So whenever a question is there, power dissipation, always use a formula P is equals to I square R. Always. Because look, the lawn mower is labeled 1200 watts. But because of its resistance of the circuit and the current which is passing, it produce heat energy and some of the energy will be lost. So that power loss is always I square R. So the current was 5.12 square multiplied by like this. The last value was 5.2. So this was 5.22 square. Multiply the resistance was 0.3. So when you multiply, you got 8.1 watts. So means out of 1200, 8.1 watt of energy is actually wasted or lost. Remaining is transferred. Is it clear? Part B2. Why can't we use 230? So we have the next question, 230 over 5.1. No, that is for the previous question. One of the student asked like why we cannot use a formula to get the resistance 230 over 5.2. But in the question, they did not mention how the circuits are connected. And that's why we are not using that formula. Like how the 230, it's not, as you can see here in the question, the main electric cable is used as an extension lead to the land mover. So this, and then we have a land mover. And it is connected to the main supply of 230. This wire is having a resistance of 0.3 ohm. And the current which is passing through the wire is 5.1, 5.2 ampere. So we use a formula that P is equals to I square R. When we use that, we know how much energy is wasted in the wire and remaining of the energy is transferred to this land mover. Lawn mover. That is what is done here. The power is 1200 watts and the supply is 230, but some of the power is lost in the wire and remaining is transferred to the lawn mover. So if you do if you do 230 divided by 5.1, you will get the resistance, but that is not giving a resistance of a wire. That is giving you the resistance of the lawn mower. The question is, what is the power dissipated in a live conductor? Yeah, that was a question itself. Calculate the rate at which energy is dissipated in the live conductor. Like how much energy dissipated in the live conductor, not the lawn mower. That's why we use a resistance of 0.3. The next question is just explanation of a graph, the IV graph for a variation of a current and the potential difference for a diode. Explain the shape of the graph in 3 marks. So the structure answer you have to learn, especially for these IV graphs. I will read some points here. Like first thing you will mention, the current is zero for the negative voltage. Like when we connect other way around, there is no current. Like when we connect this diode other way around, there is no current. So current is zero when a negative terminal is connected to the diode, directly to diode. But there will be a current when a positive terminal is connected to the P type. So the current is zero from the negative voltage. As you can see, or no current is there. And then when we reverse the current, the diode is not conducting. It has its internal resistance, which is infinite. Because this part, the diode is having infinite resistance, does not allow the current to flow at all. Even though the voltage is it should conduct, but it is not conducting because the voltage is not sufficient, so the charges can cross the barrier. And then when we increase the more voltage, the current increases. It means the resistance of a diode start to decrease. So the points, first, the current is zero when the voltage is negative. The second is current is only in one direction and the resistance is infinite initially or very high for a small voltage. When the voltage increases, the current also increases, so the resistance of a diode is decreasing. How negative voltage? The term negative voltage means like opposite way you connect it. Like say this is a positive voltage, this is a negative voltage. So when you connect a diode P with a positive, this is we call positive voltage. And when we connect the diode other way around, we call that as a negative voltage. So in this way, the diode does not conduct at all. But when we change the terminal positive voltage, the diode still have infinite resistance or a very high resistance. And then eventually further increase for a small voltage, infinite resistance. But as we increase the voltage, the current also increase. So the resistance of a diode is decreasing. Is it clear this one? The question 38 about the IV graphs. So that is the last part. Any question or doubt related to the class?